In the early years of big data, Hadoop was more or less being considered as a synonym of big data. It's even still the standard when it comes to on-premises big data environments, even though public cloud offerings hiding the complexity of big data environments are becoming more and more popular. Not all of those necessarily rely on Hadoop, but still quite a lot, especially upon the Hadoop Distributed File System, HDFS. Let's start with the phrase that Apache NiFi is not dependent on Hadoop, but it integrates very well with the entire Hadoop ecosystem. To the main reasons for this certainly belongs the relatively easy setup and management of a NiFi cluster, together with the wide choice of pre-built processors, such as for HDFS, Hive, Spark, Kafka, HBase, and so on. Then there are further Hadoop-specific tools facilitating the entire authorization and metadata management of NiFi, such as Apache Ranger and Apache Atlas, respectively. Also, the number of big data tools has been growing rapidly. It's sometimes even difficult to keep staying up to date and to keep an overview which tool fits best for a certain use case. Apache NiFi, for example, generally covers a broad range of different functionalities, which can also be found in other popular big data tools. Of course, the tools covered here could be infinite. That's why there are only tools covered which are well known and having a very specific application. Let's start with Apache Flume. Some time ago, Apache Flume was the de facto standard tool for streaming log and event data into Hadoop. Flume is totally event-driven. It's not something you would trigger on a scheduled basis. It's a command line interface tool that runs continuously and reacts to new data being presented to it. In contrast to Apache NiFi, Flume does only one specific job, just moving data from one place to another. That means nowadays Apache NiFi is certainly superior in most scenarios, even though event-driven data moving is something Apache NiFi is not entirely capable of. The next tool is Apache Scoop, which has also been around for a very long time, and though it is still the way to go when it comes to transferring data between relational databases and Hadoop. Scoop can execute bulk data transfer in parallel, and generally integrates well in the Hadoop ecosystem. Moreover, it can load parts of tables whenever they are updated, since it also offers the facility of incremental loading data. Apache NiFi's capabilities regarding this are a bit limited. However, you can also trigger Scoop jobs through Apache NiFi. Apache Storm is the next tool which we will compare with Apache NiFi. Storm is a distributed streaming processing computation framework that can process data streams extremely fast and in arbitrarily complex ways. With Apache NiFi you can also add some basic transformations and calculations, but you should keep them simple for not interfering the flow of data. The next tool we will address is Apache Airflow, developed by Airbnb. It's quite young compared to the others, but it has been gaining a lot of attention lately. Airflow is an in Python developed platform to programmatically author, schedule and monitor workflows, illustrated as directed acyclic graphs. It becomes useful for the orchestration of complex and interdependent processes. In order to orchestrate a common data integration pipeline, the capabilities of Apache NiFi are largely sufficient and do not require any other tool. The last tool which we will address is Apache Kafka, which has been widely used to build reliable data streaming solutions. It's a scalable, fault-tolerant, publish-subscribe messaging system that enables you to build distributed applications with extremely high throughput. So sometimes combining such tools may appear a little bit wasteful, as Apache NiFi covers anyway lots of functionalities. However, especially in the case of Apache Kafka, it makes indeed sense combining these tools. NiFi can take advantage of the Kafka's reliable stream data storage while taking care of the data flow challenges that Kafka was not designed to solve.